Section E, the quadratic formula.
As we said, it is not always practical or possible to factor an equation, but it is always possible to find the roots of a quadratic equation by the use of another method, the quadratic formula.
We were determined to stay on course behind Wienerkraft and the X, but we came to a problem we just couldn't solve. No matter how much we tried and erred, we couldn't factor it. We didn't know what route to take.
Remember, we found a formula for the root of a linear equation to be negative b divided by m. In the case of quadratic equations, the root-finding formula is, well, somewhat more complicated. The quadratic formula is x equals negative b plus or minus the square root of the quantity b squared minus 4ac, all divided by 2a.
Yeah, it looks nasty, but don't stress. It's a cakewalk.
By plugging in the values of the coefficients for a, b, and c, you can always come up with the roots of the quadratic equation. Again, using this method of quadratic magic, you may find 2, 1, or 0 real roots.
Okay, now for the rest of the quadratic formula. Remember the equation we failed to factor before? It was x squared plus 5x plus 3. Well, now we can factor it. You can always use the quadratic formula to find roots of equations that you can't factor any other way.
Here's how to use the quadratic formula to find roots. In our equation, a equals 1, b equals 5, and c equals 3. Now, to make things a little easier, before we substitute all these into the quadratic formula, let's just compute the part inside the square root. b squared minus 4ac, which equals 5 squared, minus 4 times 1 times 3, which equals 25 minus 12, which equals 13.
The rest of the formula is now easier to manage. We have x equals negative 5 plus or minus radical 13 over 2. Of course, that is really two answers. Using the plus part of the plus or minus sign, it is negative 5 plus radical 13 over 2. And using the minus part, we get negative 5 minus radical 13 over 2.
Radical, dude!
These cannot be expressed exactly as a decimal or fractional form. If you want to, you can compute accurate decimal approximations with a calculator. If you do, remember to add or subtract radical 13 from negative 5 first, and then divide that result by 2. Rounding to 6 decimal places, we get x equals negative 4.302776 and x equals negative 0.697224. But normally, you can just leave the answers in radical form.
Hi, my name is Miss Arts. Today we're going to discuss lesson 11.3, which is solving quadratic equations by the quadratic formula. First, we have to define the quadratic formula itself. The solution of a quadratic equation in the form ax squared plus bx plus c equals 0 are given by the formula x equals negative b plus minus square root of b squared minus 4ac over 2a. Why use the quadratic formula? The quadratic formula allows you to solve any quadratic equation, even if you can't factor it. Let's take a look at example number 1. You want to solve the quadratic equation by using the quadratic formula. The given equation is 2x squared plus 7x minus 11 equals 0. Our first step to define the coefficients. Coefficient 8, a is 2. Coefficient B is 7. And the coefficient C is -11. You always have to watch for the sign when you're stating coefficients. My next step is recall the formula. And the following step is plug in values of the coefficients A, B, and C into the given formula. B is 7, A is 2, C is -11, and A is 2. So as you see, I like to use parentheses, because parentheses will help me to avoid mistakes. Another question you can ask me, where did you get -4? The formula doesn't have -4. But you just have to remember, for the simplicity, we always have to remember that subtraction could be written as an addition of the opposite. So instead of writing -4, I would prefer to write plus and -4 inside the parentheses. This way, I won't be making a mistake when I multiply -4 by 2 and -11. My next step is simplifying the square root expression, and under the square root expression, we have to follow the priority of operations. First thing I have to do, I have to raise 7 to the second power, which is 49. My second step in simplifying under square root expression is multiplying -4 times 2 times -11, which becomes positive 88. So under the square root, I have 49 plus 88. So the last step in simplifying under square root expression is to adding up 49 and 88 is 137. My next step is taking square root of 137. And if you take a punch it on your calculator, 137 is not a perfect square. It means that we'll be having decimals. In this case, I would like to use only one decimal place, and the square root of 137 is approximately 11.7. Another thing you have to notice that square root is gone, and 11.7 doesn't have any square root. Now, the confusing thing about this expression is why do we have plus and minus and how we can handle it. So plus and minus basically means that we have two solutions, and now this formula, this expression, should be split into different expressions, which should be calculated separately. First, it should be -7 minus 11.7 divided by 4. Don't forget that you have to do the numerator first and then divide by the 4. And my first solution is -4.68. And accordingly, my second solution is -7 plus 11.7 divided by 4, and it is 1.18. You always have to remember that quadratic equation has always two solutions, because the nature of the graph of the quadratic equation, which we discussed before. So the graph of the quadratic equation is the parabola, or it is a curve. And solutions are the points where parabola crosses x-axis. And since parabola is a curve, it will cross x-axis in our case 2 times. That's why we have 2 different solutions, so 2 different points where our parabola crosses the x-axis. Now I want you to practice your theorem. I want you to solve x squared plus 12x plus 20 equals 0 by using quadratic formula. And in this case, I'm going to help you a little bit. I want us to make sure that you stated your coefficients appropriately. A is 1, B is 12 and C is 20. Now, at this point, I want you to stop watching this video, try to solve this equation, and then come back and check your answers. This equation has two answers. X is -10 and -2. In the case if you didn't get the right answers, I would like to go over and show you step by step how did I get it. Since we already stated our coefficients, we have to write down the quadratic formula, and then plug into the quadratic formula values of A, B, and C. Then simplify the under square root expression, which becomes 144 minus 80, or it is square root of 64. And in this case, 64 is a perfect square, so punching 64 in the square root of 64 in your calculator, you will get answer 8. And you see 8 doesn't have the square root anymore. Like we did before, plus minus sign, double sign of addition and subtraction, means that we have to split our solutions. First one is -12 minus 8, which is -20 over 2, and first x is -10. The second x is -12 plus 8 over 2. Don't forget that you have to simplify the numerator first and then divide by the numerator. So, a given equation has two solutions, -10 and -2. Let's take a look at example number 2 and see what kind of solutions we'll get in this case. Solve using the quadratic formula, x squared minus 5x plus 12 equals 0. First step, write quadratic formula, and then we have to state the coefficients. A is 1, B is -5, and C is +12. The following step, plugging the values of the coefficients into the quadratic formula. So now you see how it is helpful to use parentheses right now, because B is not now -5, and the B itself in the formula is negative, so we have double negative sign which will cancel each other. Another thing which is good about the parentheses, now if I place -5 inside the parentheses, and if I include the parentheses, punch the parentheses in on a calculator, I will get right answer, because without the parentheses your calculator will give you wrong answer. -5 squared will give you -25. If you put it inside the parentheses minus 5 to the second power, then it will give you the right answer, which is 25. Just remember that any number to the second power is positive. For example, -5 times -5 is +25, and also 5 times 5 is +25. Simplify the under square root expression, and you end up with the answer, which is 5 plus minus square root of -23 over 2. Now there is a kind of complication here. When you try to punch on your calculator -23 and take the square root of -23, you'll get an error message. Why your calculator won't give you the answer? Because there is no real numbers. If you take the negative square root of 23, you won't be able to get any answer in set of real numbers. So you should keep the answer how it is, with the square root and the -23 under the square root. Or you can split it in two different answers. You can write it down. X equals 5 plus square root of -23 over 2, or x equals 5 minus square root of negative 23 over 2. This example concludes our lesson.